Hello and welcome to Kognito Key. I am absolutely thrilled to have you here with us today. Are you ready to unlock another fascinating concept in the digital world? Today, we are demystifying the hexadecimal number system. Now, I know it sounds like a massive, highly complicated mathematical term, but I promise you, by the end of this explainer, you're going to see exactly how elegant, simple, and absolutely essential it is for literally every digital device operating around us.
Here's a super quick roadmap for today. We'll start with the binary problem, introduce the base 16 solution, learn about counting with letters, do a few rapid conversions, and then wrap up with why it matters.
All right, kicking things off with the binary problem.
To truly appreciate why we even need hexadecimal, we first have to look at the massive elephant in the room when it comes to the language of computers. So let me ask you this. What happens when binary numbers get too big? You see, the binary representation for small numbers is wonderfully simple, right? Counting to 5 or 10 is an absolute breeze. But think about the massive data sets researchers and engineers deal with every single day. We are talking about numbers with 32 digits, 64 digits, or even more.
A long string consisting entirely of zeros and ones is just incredibly difficult to read, and it's even harder to write out accurately. Imagine staring at a monitor all day trying to process 64 binary digits. There is a huge possibility for error. I mean, a single missed 0 or 1 and the whole data changes. It's absolute chaos.
And that brings us right to the base 16 solution.
Engineers desperately needed a shortcut to condense that chaotic data into something readable and manageable. Enter the hexadecimal system. The word itself actually breaks down beautifully. Hex means 6 and decimal means 10. Add them together and you get 16, which is exactly why it's widely known as the base 16 number system. It is built on exactly 16 unique elements.
But here's the real game changer. Hexadecimal reduces the length of a binary number representation by a massive 1/4. Now, you might be thinking of the octal system, which also shrinks binary strings, but that only reduces it by a third. Hexadecimal is way more powerful because you literally only need one single hex digit to represent 4 whole binary digits. It is incredibly efficient.
Moving right along to counting with letters.
Because we have 16 unique elements to play with, our standard 0 through 9 digits just aren't enough. We need more symbols to count higher. But if we wrote out the number 10, it would be super confusing, right? You wouldn't know if it's a decimal 10 or a hexadecimal 10. So we use this really clever substitution. A represents 10, B is 11, C is 12, and so on, all the way up to F for 15. This alphabetic swap is absolutely key to keeping base 16 completely distinct.
Okay, next up, conversions.
It's fascinating how seamlessly we can translate between these digital languages. Converting binary to hex is wonderfully straightforward. You just group your binary bits into clusters of 4, starting from the right side, the least significant bit, and moving left. Then swap each group for its single hexadecimal equivalent. Oh, and a quick trick. If your final group on the far left is short a few digits, just pad it out with zeros to make a complete set of 4. Simple, right?
Going backwards from hex to binary is just as fast. You basically explode one hexadecimal digit out into its full 4-digit binary sequence. Just write them out in order, and boom, you instantly have your binary equivalent.
Now, to translate hex back into our everyday decimal system, you simply multiply each hex digit by 16 raised to the power of its positional value, and then add it all up. As you move left, the positive power increases, and if you're dealing with decimals, moving right increases the negative power. Finally, just calculate the sum.
And finally, let's look at why it matters.
So why does all of this mathematical translation actually matter in the real world? Well, because of its incredible ability to safely and accurately compress long data strings, hexadecimal forms the absolute backbone of modern digital systems. From the complex microprocessors in your computer to the tiny microcontrollers running your home appliances, it is extensively used everywhere. It condenses massive amounts of binary instructions into clean, readable code that engineers can actually write and troubleshoot efficiently.
I will leave you with this provocative thought. As our digital systems and data sets continue to grow in massive complexity, will base 16 always be enough? Or will we eventually need to build a brand new shortcut? Well, I hope this explainer made the logic of hexadecimal perfectly clear for you today. If you found it valuable, please subscribe to Kognito Key, hit that like button, and share this explainer with your friends. Thank you so much for learning with me today, and keep exploring.